Alright, let me restart again. So I've already gone through in terms of understanding what is this manual calculation, and then followed by using a buffer calculator, right? So already done the buffer calculator, and one of the popular one is actually this Kusabio. Of course, there are other buffer calculators available in the website, but they do cease to exist because this is websites. They may not no longer exist after some time. We now move our attention to buffer capacity. There's the definition given there. You may read it, but I want to just highlight the fact that it is an amount of acid or strong acid, normally 1 molar of HCl, sulfuric H2SO4, uh, sulfuric acid, or strong base like 1 molar NOH, to be put into the buffer until there is a change of 1 unit. Okay, so that's the meaning of buffering capacity. So just to see how much of volume required for this strong acid or strong base to move it 1 unit exactly. Okay, and then there is also given in terms of its definition, in terms of the changes happening of pH. But I just want to draw your attention to the line here. Okay, so it says here that after you make the titration curve, the maximum, uh, that means it's strongest in terms of its buffering capacity when the pH is close to its pKa. Okay, so that means when you do the titration curve and you know the pKa of that buffer is where, that's where it's the strongest. So let me demonstrate what's the meaning of this. But before that, I just want to read this statement here. The buffer capacity has reasonably high values. Okay, that means it's highest in terms of its buffering capacity when the pH is close to the pKa value. Okay, so let's look at this titration curve here. Here they put acid on this side and then followed by base on this side, and this is the type of curve they managed to obtain for the sodium phosphate buffer. And based on this explanation, the buffering capacity should be the strongest here. That means when you add pH, say 1 molar of hydrochloric acid, it will be withstanding in not so much of changes in the buffer pH. In comparison, if you were to add hydrochloric acid here, it will immediately change to a bigger extent in terms of pH change comparison to somewhere close to its pK value. Same goes if you were to add NOH, the changes will be much lesser here compared to if you look at the curve, it will change much faster. Okay, so that's the meaning. And then another thing that I want to draw your attention is actually the range. So you want to know what's the range. Oh, I think I got that. Okay, so you want to know what's the range of the pH. You need to draw a line, probably somewhere here, and here is considered. You have to make a guesswork because it's a sigmoidal graph. So this will be considered the pH range for this sodium phosphate buffer. Okay, so I hope you understand. So moving on to actually doing an experiment altogether. By right, if you were in the lab, you will be doing this experiment, but unfortunately we cannot foresee that to happen, at least for this semester. So what do you need to do is to actually prepare something of a standard, or sorry, titration curve. Just like this, it will look somewhat like that. So how do you do it? First, you gotta prepare the zero point 0.1 molar sodium acetate buffer. Please look at the video I already uploaded on preparation of such a solution by using uh, the most appropriate equation. Okay, and then you also to prepare hydrochloric acid 0.1 molar. Again, please look at how to prepare and let me know in your report, assuming you already prepared. But make sure for the preparation part, you need to use a volumetric flask. Okay, find out what is a volumetric flask. Uh, it has a meniscus. Okay, say it is say 100 ml. Got various types of volumetric flasks. Okay, right. So you also need to find out how to calibrate a pH meter. How does a pH meter looks like? Okay, so I already given a video, so please watch the video. Unfortunately, you will not be able to touch the pH meter yet, so you have to have a theoretical understanding rather than practical understanding about a pH meter. So what you need to do is using a burette. I hope you know what's a burette. If not, please Google what is a burette. It is a long cylindrical uh, glassware or equipment, and then at the end of it, it is drops, and then it has a lot of lines with different volume measurements. Okay? Normally we use a 50 ml burette. Okay, just to have it, line is a bit too thick. Okay, right, so please have a look what is a burette. So what you do is the acid, zero point 0.1 molar hydrochloric acid, is to be poured inside uh, hydrochloric acid. Next, you have at the bottom a uh, aluminium flask. Yeah, aluminium flask. Okay, and then you, oh sorry, you put 30 ml, not okay. So put 30 ml as instructed, the hydrochloric acid, and then from the burette to, oh sorry, sorry, yeah, you ensure there is 50 ml here of HCl, and then here is 30 ml of the sodium acetate solution. So drop wise, add every time 1 ml of the acid, and then you stir the aluminium flask which has the sodium acetate as well as 1 ml of HCl. After that, using the pH meter, put the probe inside and measure. So now 1 ml of HCl added, what will be the pH? Okay, so you do like this, after every 1 ml you add. So you add 1 ml, you measure the pH, add another 1 ml, measure the pH, add another 1 ml, you add the what you call measure the pH. You continually do this until you get many readings, and then you can see they ask you to plot titration graph of y-axis represent the pH and the x-axis to represent the volume. So hopefully you will get a graph like this as well, a sigmoidal graph, and then answer the questions, these questions. But since we can't do this in the laboratory, so I make this icon that says is online learning. So this task and task 1 and 2, you are only to describe to me how you prepare. Task 3, this one, you are given a video to watch. Task 4, I will give you hypothetical result of the volume and also the corresponding pH to enable you to do the titration graph. Okay, and then please answer this question. Determine the volume of HCl needed to make 0.1 molar sodium acetate solution at pH 5. I'm not going to reveal so much. You need to do your part of finding out what the volume is from the graph. Determine also the range of pH. I think this is straightforward. I just given you an idea on how to determine the range. Right. So that's done on part 1 in terms of lab work. We now look into preparing buffers and evaluating their buffering capacity. So for preparing buffers, I have given quite a number of choices to prepare, but A and B is actually the same buffer, that is acetate buffer, only pH varies, pH 5 and pH 8. 5.8. Okay, and then also given the solution to prepare it. So how do you gather information on preparing it? I suggest you go to what was given, uh, one of these, but usually Kusabayo is the best choice. Okay, and then you put in all the information and get how to prepare this acetate buffer at pH 5 and 5.8, and then also tris buffer. I also have given phosphate buffer solution. So all this also with mysterious challenge given. I want to see whether you can able to meet up to my challenge within this A, B, C, D. So let's see how you answer to it without contacting me. Okay, right. Next, I have asked you to just focus on A and B. This A and B. How to determine which one has a better buffering capacity? Recall back, both are same acetate buffer, except they are what you call uh, the pH is different. That is, one is pH 5 and the other one is 5.8. All right. So little bit of procedure given, but this is supposedly should be done in the lab. But I also have online learning. So let's look at the procedures in the lab first. First, calculate the volume of stock required to each buffer solution to be prepared. Yeah, this is the old way, manual way. Next, prepare accordingly the buffer. Okay, then measure the pH using a pH meter, And then lastly, determine the buffer capacity of two of the acetate buffer. I only ask for A and B, not all. And then how to do it is actually to add uh, 1 molar of HCl until there is a change of exactly 1 unit pH. So okay, since you let's look at the online learning now, since you can't be in the lab. So prepare buffer solution ABCD. As I said, go to Kusa Bio, the best one. Describe hypothetically in your report how you will prepare all this after you go through the Kusa Bio website. And then for A and B alone, please determine how changes happen if you drop HCl 1 molar, exactly 1 unit. Since you can't do it in the lab, so I have no choice but to give you hypothetical result as well. Okay, so after that, use it to answer this question. Are the buffer prepared by you considered to be effective in their function? Compare them. Most probably you have to compare A and B. What apparatus you chose to deliver certain solution in this experiment? What are all this apparatus? Since you are not in the lab, try to figure out what can you conclude regarding the buffer capacity determined. Okay, so that's it in terms of this practical video. Hopefully it will be helpful when you prepare the report. Again, unable to do it in practicality, but more so of theoretical. So you have to ensure that you refer to much of YouTube available videos on, say, pH meter, use of burette, use of volumetric plus, use of Erlenmeyer. How does the Erlenmeyer flask look like for that matter? Okay, and also this buffer calculator. All right, I end my session of the video for this preparation of buffer solution.